Hello everyone, my name is IROS'23. I'm a PhD candidate at Brown University working with Stephanie Pellets and George Fernandez. I'm going to be presenting my work on improved inference of human intent by combining plan recognition and language feedback. Our work is in collaboration with Arizona State University. Conversational assisted robots can aid people, especially with cognitive impairments, in accomplishing various daily tasks such as cooking meals, performing exercises, or operating machines. However, for the robot to interact effectively, the robot, given noisy observation in this partially observable environment, must be able to infer the human intent. That is, it must be able to recognize the plan, that is, what is the next step that the human is going to do, and it must also be able to recognize the goal that the human is trying to achieve. For goal and plan recognition as planning, substantial research have been done over the past decade. However, all of these works, they cannot handle suboptimal human actions, human doing multiple concurrent goals, or human giving a language feedback. Now, in order to be able to handle all of these challenges together, we present a novel formulation where we assume that the human is a hierarchical task network with goals and sub-goals. We represent our robot as a partially observable decision agent. Given the noisy observation, our robot now performs delete, update, and goal recognition. And in ambiguous settings, it can ask classification questions and update its beliefs given the language feedback. I'm not going into the details of the formulation of our PalmDB problem formulation, but please refer to our paper and I'll be more than happy to answer any questions that you have offline. We call our algorithm as dialogue for goal recognition. We evaluate the performance of our dagger over two simulated domains, that is kitchen and blocks, with varying sensor reliability from 99% to 80%. And we compare it with three other baselines, which is SNPs, introduced in 2020, HTN, which models the human as an HTN but does not incorporate language feedback, and then Oracle, which models the human as an HTN and always asks the correct question. We present the results that Dagger formulation accumulates 58% higher reward than the Oracle baseline by asking 68% fewer questions. Further, Dagger outperforms HBM by estimating the goal state by 2.8% better in the kitchen domain, 1.84% better in the blocks domain, and this is overall 3% less accurate than the Oracle baseline. Here is a demo where I am going to be presenting how our robot curry is able to track progress of the human as the human tries to do two goals, which is make coffee and wash hands. In this demo, the human performs suboptimally and also switches between the goals.
Please note that Google's speech detection algorithm is used for the language observations, and simulated world sensors are used for the world state observation. The user starts with the goal of making coffee. Turn on faucet is a shared action, primitive action between all the three goals: make coffee, wash hands, and make tea. And you'll see that for the shared goal, the curry robot doesn't ask a question. As soon as a human performs an action that can help Curry or our algorithm differentiate between the goals, our algorithm decides to ask a clarification question.
I believe you performed at water kettle 1. Is this correct?
Hey Curry, this is correct. Now the human continues with making coffee. Now the human starts a new goal, which is wash hand, and performs the first step for that is turning on faucet. Now human performs suboptimally for the goal wash hands and forgets to do the action use soap. Rather, they turn off the faucet directly. Our algorithm recognizes the suboptimal action and asks a clarification question.
I believe you performed use soap. Is this correct?
Hey Curry. No, I have not.
The correct action for you to perform is use soap.
Thank you. I'll do that now.
In conclusion, our research opens venues for language grounding and human intent recognition in human robot tuning. Further, we show and demonstrate that modeling the user as an HTN and incorporating language feedback improves the accuracy of the robot's relief of the human progress. Further, we also show that farm duties are an effective way for tracking the task's progress and user engagement. Thank you so much for listening to my presentation, and I will be more than happy to answer any questions that you have. Thank you so much.